In today's lesson, we're going to be learning about relations and functions. The definition of a relation is that it's a set of ordered pairs. Ordered pairs are points, and let's always remember that our points are in the order x, comma, y. The definition of a function is it's a relationship between values with specifically each input having exactly one output. The inputs will be referring to our x values, and the outputs will be referring to our y values. To test whether a relation is a function, we go ahead and use these two kind of tests. The first test is that when you're given an ordered pair, you have to look at the x values. If the x values are repeat, it's not a function. I like to think of it like x is wrong. So if I see more than one of the same x, I know it's not a function. Given a graph, our test is going to be the vertical line test. Remember, vertical lines will be up to down, straight up to down there. That would be a vertical line. If a vertical line intersects a graph more than once, then it is not a function. Let's go ahead and look at 4 examples here. For the first example, we want to determine if the following are functions and explain our reasoning. The first example, I want to look at my x value specifically. I got -4 going to 3, -2 going to 0, 1 going to -1, 2 going to 0, and 5 going to -2. There are no repeating x values. They are all different, and they all go to one output of a y value. So a good explanation you could say is that yes, it's a function because the x values do not repeat. Each input it has exactly one output. For example B, when it's on a graph, we draw vertical lines all the way through our graph here. Notice that all of these I'm drawing so far have only hit one point. But when I go ahead and draw this vertical line here, I am touching my graph twice, more than one point. This is not going to be a function because it fails that vertical line test. That vertical line I just drew touches 2 points, not just one. For C, we have a mapping. How mappings work is that the arrow should just be coming from x once here. So -4 goes to 4, -2 goes to just 3, and 1 goes to 7. But notice what is incorrect here. We have my arrow from -1 going to 0 and an arrow from -1 going to 7. In red, that is where it becomes not a function because the input x value of that -1 has two arrows, two outputs going to 0 and 7. That's not possible, not for a function. In example D, I'm going to again look at my x values. I go ahead and circle or highlight my x values, which remember are the first values in front of your comma. It's -4, -3, -2, -1, -3. I notice that I have a repeating x, so I state that it's not a function. The input of -2 is used twice with different outputs. The first output on -3 is -1 in this ordered pair, my second ordered pair. And then in the last ordered pair, when I also have an x value of -3, my output is 2. They do not match. It is going to be not a function. We have function notation. Anytime you have an equation like y equals 2x minus 8, it can be rewritten as instead of y, f of x is how we read this. It's an f with parentheses x, but it's read as f of x equals that 2x minus 8. Notice I kept the 2x minus 8. All I changed out was y to its equivalent form of f of x. It's just how we signify functions in their specific notation. To evaluate functions for a specific value, we go ahead and substitute the value in for x every time it appears in the function. Note that for column C in the tables below, we will substitute the value in for f of x entirely. Then solve for the input value of x. We'll get to that column when we go to example C. But let's look at example number 2. We have our function up here. I'll go ahead and highlight it in light pink, that f of x equals x plus 7. For the example A here, we have f of 5. So right away, I'm going to go ahead and establish that x is going to be 5 here. That means every time I have x in my function, I'm going to go ahead and erase and replace it with the 5 that I know x to be my input here. And again, every time I have it, I go ahead and erase and replace it. From here, I'm going to go ahead and keep the left side notation that reads f of 5 here. That's going to stay. What I need to evaluate is my right side here. Because I can combine with order of operations 5 plus 7 to get 12, and that's going to be what f of 5 equals, which was what my question was asking. Let's go ahead and try the next example. For the next example, I have f of negative 1. Well, right away, I'm going to establish that x equals negative 1. So instead of f of x equals x plus 7, I go ahead and erase and replace my x values with a negative 1. Every time I have x, I replace it with negative 1 inside my function. From here, we go ahead and keep the left side and evaluate the right side. That's just combining negative 1 plus 7, which makes a positive 6. For example C, notice that I have f of x equaling 4. I do not have an x value, so I'm going to go ahead and make a note that I'm going to keep my x value inside this function. F of x equals x plus 7. But what f of x is equal to is 4. So what I'm going to go ahead and do is take f of x and replace it with what it's equal to, which is 4. I just read out loud that f of x equals 4, so I can swap out the whole f of x term into 4. From here, because I'm keeping x, I have to solve for x. So to get x by itself, it's x plus 7. Opposite of addition is subtracting that 7. What you do on one side, you have to do to the other. It cancels out on the right. And 4 minus 7 is negative 3 on the left here. X is equal to negative 3 is our final answer. And we can go ahead and try example 3. For example 3, let's highlight in orange our new function. We have g of x equals 2/3 x minus 1. Right away for my first example A, I have g of 9. That means my input, my x value is 9. That time I have in my function x, both in the parentheses and next to the 2/3. I will erase and replace that x with 9 in this case. When I replace it, I'll go ahead and use those parentheses in both cases, so that way I know it's 2/3 times 9. Multiplication comes before subtraction. I put that 9 over 1. I multiply the two numbers in the numerator. That's 9 times 2, which is 18. Then I multiply the two numbers in the denominator. 3 times 1 is 3. Don't forget the subtraction of 1, and the g of 9 is going to get brought down. You can write it each time if you want, but I'm just going to draw a long arrow down because I'll eventually write the notation at the bottom. Next comes division of 18 by 3 here, being 6, where I will then subtract 1. Again, when I go to my order of operations, I'm going to write my reminder over here of PEMDAS. Parentheses that would also include grouping, exponents, multiplication, division, addition, subtraction. Final answer here, 6 minus 1 is 5, and that will be equal to g of 9 here. That's what our problem was asking for. That's what we solved. Next example, we have g of negative 6. So our x value that we're replacing is negative 6. So in my function, g of x equaling 2/3 x minus 1, I erase every time I have x and replace it with a 6 here, using parentheses, and make sure that 6 is negative specifically here. Again, once you have that answer, that left side is just for notation purposes, and the right side is what you evaluate and solve using your order of operations. We're going to go ahead and multiply here. We put the negative 6 over 1, and we multiply the two numbers in the numerator. 2 times negative 6 is negative 12. And two numbers in the denominator, 3 times 1 is 3. Don't forget about your subtraction of 1 that you have to bring down. Next in our order of operations is division. So we go ahead and get negative 12 divided by 3, being negative 4. That then will be subtracted by 1. Negative 4 minus 1 is negative 5, and that is equal to the g of negative 6 the problem was asking for. I just bring down the left side for notation purposes in the end. It's not the part I'm solving. For example C, remember when you have g of x equaling a number, when the number is not inside the parentheses and x is kept, we have to do this operation here. I take the g of x equaling negative 1, and I'm going to go ahead and erase and replace g of x entirely. I keep x, but I erase the whole left side and put it what it's equivalent to, which is going to be 1. That g of x equals 1. So I take the whole g of x and have it as 1. From here, we draw our line and solve, because when we keep x, we got to solve for x. I add 1 to both sides because I want to get x by itself. Subtraction of 1 needs the addition of 1 on each side. 1 plus 1 is 2, and the 1 minus 1 cancels out on the right here. 2 divided by 3 requires a multiplication of 3 to move it away from x. That cancels out the division of 3 on the right side, leaving me with just 2 with x. And on the left side, 3 times 2 is 6. From here, to separate 2 times x, I have to do the opposite of multiplication, which is division. And what I do to one side, I have to do to the other. Leaves me with just 1x on the right and 6 divided by 2, which is 3 on the left here. Last example, number 4, again in orange, I will go ahead and highlight my actual function, in this case, h of x. What I go ahead and do and realize in the first problem is that my x value is going to be negative 3 here. So my function is h of x equals 2x squared plus 5. I erase and replace my x values with a -3 in both cases. When I erase and replace them, I want to use parentheses to help me out here. Make sure that you remember PEMDAS. The parentheses are there with a -3 inside. So once I get the parentheses down to one number, I then keep going in my PEMDAS. The next thing is exponents. That's what I'm going to do here. My -3 squared is what I do first. Well, that is just -3 times -3, which is going to be a +9. Keep it in parentheses. It is multiplied to 2. So again, one number in parentheses is just multiplication. 2 times 9 is 18. And then I will add 5 because again, I'm going with my order of operations. 18 plus 5 is 23. And h of -3 is what that 23 equals to. That's just the notation at the end. Again, you're never solving that left side here when you have a number in parentheses. H of 0, numbers in parentheses, just like I mentioned. So that's going to be x equaling 0. Inside my function, which is h of x equaling 2x squared plus 5, I erase and replace my x because I have a different input here. X I know as 0. And again, when I erase and replace, I use parentheses to help me replace whatever the x value in the parentheses is if given. From here, exponents still come first after my parentheses gets down to a number. Well, 0 squared is just going to go ahead and be 0. That will be multiplied to the 2 plus 5. If you want to write the multiplication like I did here with a dot instead of those parentheses to help you out, that's fine. It's just multiplication once you got one number left in your parentheses. From here, we bring down the left side, keep going with it. Right side, we still solve. 2 times 0 is 0. Then we add 5 because we're going with the order of operations. Left side we bring down, and right side equals 5. H of 0 equals 5 is our answer for example 4b. Last example, we have example 4c. We have h of x equals 5. When we have an equal sign, I like to box the whole thing and remind myself that I'll be keeping and solving for x. Well, we have f of x, h of x specifically in this case, going to be 2x squared plus 5. I don't know what x is because x is still in the parentheses. So what I need to have now is the h of x equaling 5. That equals 5, so I erase that whole h of x and replace it with what it's equal to, which is 5. I don't know x, but I do know h of x equals 5. Because I still have x in my function, I go ahead and solve for x, think back to how to solve equations. That plus 5 needs to move away from the x by subtracting 5 on each side. 5 minus 5 canceled, and 5 minus 5 is 0. Bring down the 2x squared I did nothing with. From here, 2 is multiplied to that x squared, so I do the opposite of multiplication to move that 2 away from x squared. And 0 divided by 2 is just 0. We're going to learn this later on, but to undo an exponent of 2, we take the square root on each side. That's the only way I can cancel out a squared, and the square root of 0 is 0. X will be equal to 0 for this last example 4c.